Stars are some of the biggest generators of energy in the entire universe. From the humble red dwarfs that burn steadily for billions of years to the biggest, densest, hottest neutron stars, they're all unimaginably huge power sources. What if we could harness the power of a star without leaving Earth at all? This is Unveiled, and today we're answering the extraordinary question, is China really building an artificial sun?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more thought-provoking content?
On December 23, 2021, a Long March 7A rocket launched from Wenchang, southern China. It was carrying 2 classified satellites, and while that would be interesting enough in its own right, a few weeks later, the Long March 7A captured the world's attention for another reason. A video of the launch went viral on social media with the caption that China had launched an artificial sun into orbit. It's true that, in flight, the rocket did look like a star, but it definitely wasn't a fake sun. However, this doesn't mean that China's top scientists aren't hard at work building something else, something that certainly is an artificial sun, or at least that will be one day. In January 2022, right around the time the Long March video was going viral, news did break that China had an artificial sun and that it had been switched on. This isn't a sun designed to be launched into space, though. It's a nuclear fusion generator seeking to replicate the stellar fusion that happens in all living stars in the universe. It's called the EAST, the Experimental Advanced Superconducting Tokamak, and is, to date, the most powerful and promising tokamak ever constructed. It ran for 1,056 seconds, or 17.5 minutes, in a world record-breaking feat, achieving temperatures of 150 million degrees Fahrenheit. In contrast, the core of the Sun reaches a temperature of 27 million degrees Fahrenheit. This means that on Earth, we've beaten the Sun's internal temperature almost 6 times over. The reason this feat is so exciting is that it means we're one step closer to finally developing a nuclear fusion generator here on Earth. All currently operating nuclear power plants work on nuclear fission as atoms are thrown together and broken apart, releasing immense energy that we use to power our homes. But nuclear fission doesn't create anywhere near as much energy as nuclear fusion, a process that only normally occurs inside stars because stars are the only places hot enough. Fusion is the process by which stars burn, taking immense amounts of hydrogen and burning it up, creating helium in the process. That helium then goes on to be fused itself into heavier and heavier elements until the star runs out and ultimately dies. Whether it dies with a whimper or a bang depends on the mass of the star, but none of them last forever. By harnessing this power, we could have an essentially endless energy source on our hands. So it's no surprise that many different countries have been working for decades on methods to achieve this, with tokamaks being one of the most promising inventions. Tokamaks were initially devised by scientists in the Soviet Union in the 1960s, and by the 70s, the concept had been proven enough that many other countries jumped on board to develop them. Indeed, the country that held the longest-running tokamak record before China broke it in 2022 was France. The French Tour Supra tokamak ran for 390 seconds in 2003, so the East beat this record 3 times over. In February 2022, the UK-based Joint European Tourist, JET, also made headlines when its tokamak produced 59 megajoules of energy over 5 seconds, a considerable amount compared to previous experiments. However, international efforts have focused mainly on the International Thermonuclear Experiment Reactor in France, which upon completion in 2025 will be the world's largest experimental tokamak nuclear fusion reactor. Tokamaks work by containing superheated plasma in a circular structure called a torus, which looks like a donut, and using that heat and plasma to generate energy. For decades, scientists around the world have been working on them, but physicists haven't yet been able to solve a few major issues in the current tokamak design. The big problem is that none of these tokamaks have been able to break even on power consumption versus power generation. As it stands, every tokamak, even the East, is consuming far more power than it's yet been able to produce. This means that they are totally unviable as power sources because they're not really power sources at all. They're more like power leeches. This is the problem that China is working at breakneck speed to try to solve. The East is never going to be a power generator, however. It has experimental in the name for a reason, and it's really just a way to test and develop the technology. The fact that it's been shattering so many world records is extremely exciting, however, and any advances in this area of science will be great for humanity, regardless of which country is leading the charge. Tokamaks, like nuclear fission, are a form of clean energy, but with even fewer risks than a traditional nuclear power plant. Though technically speaking, nuclear fission is a clean energy source, we all know what happens when something goes wrong. You can end up with an environmental catastrophe of massive proportions, even from only a few mistakes. The world is still grappling with the effects of 1986's Chernobyl disaster and the 2011 nuclear meltdown at Fukushima Daiichi in Japan. But despite the extraordinary temperatures tokamaks reach, they haven't yet shown that they have the same potential for danger. This doesn't mean that danger couldn't present itself, especially when working with such tremendously hot plasma. But tokamak failures, called disruptions, are far less dramatic than meltdowns. The worst one yet merely damaged the wall of the tokamak itself. Most happen because the plasma moves in a way we don't want it to, which means it comes into contact with the walls and immediately begins to cool. However, much like the traditional nuclear power plant, tokamaks are expensive, significantly more expensive due to their experimental nature. The East has cost China $1 trillion so far to develop, and it still hasn't been operational for longer than 17 minutes. The technology needs to get much better so that it can eventually pay for itself and fulfill its ultimate energy potential. But China remains a world leader in green energy in general. While it's true that China produces the most net carbon emissions of any country, almost a third of all of them, it's also got the largest population. Per capita, emissions in China are lower than those in the US, Russia, Japan, Canada, Germany, and many other countries besides. China has been putting hundreds of billions of dollars into green energy solutions in the pursuit of net zero, and it gets closer to this goal every year. As much as people may be concerned about nuclear energy, and despite the huge expense of developing tokamaks, harnessing nuclear fusion is a necessary part of our future. If we're ever going to leave Earth and travel to the distant reaches of the galaxy, we're going to need power sources like this. And the only power source better than an actual star is a star you can take anywhere you want. The potential for this technology is absolutely mind-blowing. A Kardashev Type 1 civilization can use and store all energy available on its planet, while a Type 2 can harness the energy of its home star. Thanks to nuclear fusion, we could potentially become a Type 2 civilization without completely becoming Type 1. As humankind's power needs continue to grow, extravagant energy solutions like this are going to become more and more important. One day, fossil fuels will run out, and when they do, it's suddenly going to be in many people's best interests to start looking for a power source like a fusion generator. Suddenly, the trillion-dollar expenditure will be nothing compared to the benefit to humans and the potential for profit, especially once tokamaks are finally up and running. They'll be self-sustaining at that point, requiring much less labor than, say, a coal mine. And unlike other renewable energy sources, We won't need to rely on Earth's climate to provide this power. If we can get such a generator working, it would be as constant as the sun itself, but without having to worry about cloudy days or nightfall. Inside the tokamak would be endless daylight, and, therefore, endless power. It's something that could even one day take us to the stars. It isn't destined to find its way into the sky, but the experimental advanced superconducting tokamak is the future of energy. And that's why China is building an artificial sun.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.